Okay, here I am to section 1-4. We're doing graphs and equations, and our objective is really to be able to find the break-even point when one equation takes over from another one, and there's a break-even point, and that'll help us make decisions about which plan or which business decision makes the most sense based on break-even point. So I've got kind of an imaginary business scenario here. Suppose we've got a Highlander t-shirt company going, and if you know about t-shirts, they get expensive if you order just a few of them. So there's a plan that has $10 per shirt. You can order 1 or 2 or 3 or 50 if you want, but it's just $10 per shirt at that plan. There's another plan that screens them with a screen that takes $20 to set up, but it's then only $7.50 a shirt. And then there's another automated machine that costs $150 to set up, but it's a high volume thing, and that brings the price down to only $5 per shirt. So which one of these plans is the best based on the number of shirts that we might be selling or ordering from this company? So I'm just going to draw an axis here, and that would represent 0 t-shirts up to, say, let's say 100 t-shirts. We're not sure of exactly where these will be. Sometimes you have to do a rough draft when we graph them. And then if I were to order 100 shirts from this plan, it's going to be $1,000. So I know that my ceiling up there should be around $1,000, and that's 0. And I guess we can do 500 and see from there. Now again, stress that a lot of times you have to do sort of a rough draft and see how it works, and you can expand it, but maybe we'll be lucky this first time. Well, graphing this one is pretty simple because it's just $10 for every shirt. So an equation that would represent this would be that the cost C for these shirts would be simply $10 for every t-shirt, and I'll use a T for that. That would mean that our intercept is at 0 and our slope is at 10. If I go out to 100 shirts, it'll cost me $1,000. So I've got a line that will go like that for that plan. Okay, my $20 screen fee shirt and $7.50 per shirt is going to be $20 for my intercept. Well, if this is 500 and this is 100, 200, on up to 500, it's going to be only $20. It's going to be hard to see. It'll be right there, but then the slope is less. So we know it is going to be something less like this, and we could come up with a further point, I guess. If we did 100 shirts, it'd be $750 plus 20, $770. So it'd be about right there. So I'm not too far off. I'm not going to redraw that, but it's going to intercept somewhere around there. And then the machine version of these t-shirts will be printed at a cost of $150 setup at only 5 per shirt. So there's 150. There's my intercept. And then if I did 100 t-shirts, that'd be 500, that'd be 650, so it'd be about right there. So this one is going to go through something like that and have a break-even point right there. So here's the point at which this first plan, plan A, is the cheapest. Here's a point after which B is the cheapest, but then this is the point at which C becomes the cheapest. So the question is really, where are these points? Okay, where are those break-even points? And we can estimate them maybe from the fact that if this is 100, maybe that's 50, so this is something below 50, and that's maybe around 10 or 20, but graphs can be a great way to get an idea, but really the best way to go on this is to use algebra, and it's really simple. So let's do it that way. If I write this equation for this one, I can write 20, the cost here, C is equal to 20 plus 7.5t for this equation, and then this one would be 150 plus 5t for this equation. That equals this cost. Well, the break-even point are when these two quantities are even, so I simply set them equal to each other. 10t equals 20 plus 7.5t, and I solve that, and that's just a really straightforward Algebra 1 type problem. Subtract 7.5t from both sides, and I get 2.5t equals 20. Divide both sides by 2.5, and you'll see 20 divided by 2.5 is exactly 8, because 2.5 goes into 10 4 times, 8 times into 20. So that's actually, after 8 t-shirts, that's when plan A is no longer the best one. At 8, they're both the same cost. Same thing we do with this. Maybe you want to pause the camera and solve it on your own, and then check back in a second and see if you've done it the same way I have. All right? Okay, you paused it. Now you're back. All right, let's see. We've got 20 plus 7.5t being equal then to, I'm going to have to erase that, 150 plus 5t. Again, we just want to solve this simple equation. I subtract 5 from both sides, so I get 2.5t. I'm going to subtract 20 from both sides. That gives me 130. Divide both sides by 2.5, and t is going to be equal to 52. All right. Again, I'm just dividing 130 by 4. Okay. So after 52 t-shirts, the high volume one is as good as this one, and anything beyond that, it's better. So those are break-even point problems. Show you how to do it in the calculator. Okay, we're going to do this t-shirt problem very quickly on the calculator. I'm going to go to y equals, and I'll notice right away that plot 1 is turned on from last lesson, so I'm going to go up there and turn that off. I just arrow up, I hit enter, and it is no longer highlighted. Those are my 3 equations. When I go to graph them, I think it's probably simplest if I simply go to my window and ask myself a few basic questions. My x variable is my number of t-shirts. Well, the fewest number of t-shirts and the minimum I could have is 0. Well, the most number of t-shirts is likely to be maybe around 100, so we'll start off with that. It's a little bit of guesswork, and you can modify that. The scale is just the little rule marks that go along the bottom. That's all it is. You can set it to 0 if you don't want any. Usually you go with something that's around 1/10 of your spread in data. From 0 to 100, 1/10 of that is 10. And my y minimum is the fewest amount of dollars I could be charged. Well, if I don't get any t-shirts, that would also be 0. Then my maximum, well, pick like the most expensive plan. If I order 100 shirts and they're $10 each, that's going to be $1,000. So I could maybe go up as high as 1,000, and my scale then would be every 100. And if I go to graph, I will see there's the first line, there's the second line, and there's the third line. Now it's hard to see exactly what's happening there, but clearly the interesting bits are all in here. I can either change my window, or I could do zoom box. If I do zoom and then just hit enter, I see that little cursor there, which I can then steer over and then draw an enlarged box for the part that's the most interesting. So I thumbtack that down by hitting enter, and you'll see that the cursor changes to be a solid, well, it's actually still a box, but it's filled in. And then I pull this open, I go down, and there is my zoom box. And I'll quickly go down to include the origin. Alright, and I hit enter, and here are my graphs now enlarged. Okay, and you'll see barely, but there are lines crossing down there, and they clearly cross up there. So if I want to find those break-even points, it's relatively straightforward. All I do is I do second and then calculate, and I choose option number 5. I just press the number 5 for intersect, and then it will ask me what the first curve is. Well, I want to make sure that my little cursor there, alright, that's on the upper curve. Well, I want to maybe find out where this line intersects down there. So I'll select that and say yes, that one. And then I'll arrow down, not to that one, but to the one below it. And right there, you can see the cursor's on that lower line. So I hit enter and enter again. There is my point of intersection. Now it's disappearing a little bit behind the word intersection, but it gives me the coordinates at 8. So at 8 t-shirts, it's going to cost me $80. That's my break-even point for the first plan.